Hi everybody, welcome back to UnityCookie.com. This is Gabriel Williams again. We've got a brand new set of really awesome tutorials, I guess depending on when you watch this, but at the moment it sure is, and I hope you're as excited as I am to get into this new series. In this case, we're going to be going from start to finish on an entire tower defense game, so one of the more popular type of games out there right now, especially with mobile games and such. So we're going to go all the way from start to end on that, show you piece by piece how to put it together, and basically make the whole game. So to start, we're going to be going through a couple things. I should make a fair warning, I guess. This is a bit of a learning experience for myself. I haven't done one of these before, but I have a pretty darn good idea, I think, and we'll basically be building it in modules. So first we'll build a couple turrets, we'll get those working well, then we'll be building just a top-down grid placement system, and then we'll go on to the enemies, put some AI on them, maybe some extra turrets if we have some time, just get some more fun ones, and then things like damaging, waves, money and such, or points. Then of course the game GUI and audio, I guess I tend to keep that towards the last. Then just good old win-lose, and finally some high scores in this one. So something that if you were maybe just finishing the Lunar Lander tutorial, we never quite got any proper high scores in there. It was something that was asked for quite a bit, so we're going to be having it in here for sure. On that note, if you haven't already gone through those or any of the previous Unity Cookie tutorials, you definitely should, unless you're already pretty up to speed on scripting and all of how Unity works. Just because we have a lot to go over in this set of tutorials, it's going to be you end up a little behind on some parts. I'll be going a little faster than usual, so it might be good to watch those first, especially Lunar Lander. It's got tons of good stuff in there. Okay, so let's move on to the fun stuff. So let's take a look at what we have here. The first tutorial we're going to be going over, like I said, just a simple starter turret, something that's going to shoot at the baddies that come by and just about nothing else. So just getting this together is fairly simple once we have the right parts. Let's take a look at how it works first. So if we're looking at the in-game screen here, if I drag in my enemy, we have this turret that will turn with a nice smooth turn and fire. Pretty simple. If I go in a little closer, you can also see, one second, so now up in the top view here, I have added in just a nice little feature where it will constantly get sort of a bit of an aired targeting, so it just makes the game a little more fun. The computer isn't always exactly on, and that's something we'll be able to control from the script with a nice little variable. Real simple for you to fine-tune and tweak exactly how all your turrets are working, or for different types and such. So that's pretty much it. Pretty simple and straightforward. Let's move on to how this all comes together. Okay, so and again, since these tutorials are going to be a bit more advanced than previous ones, or at least than the Lunar Lander tutorial, I'm trying things a little differently here, and feel free to let me know in the comments if it worked for you, if it didn't, but it should enable us to go through these quicker and get you moving without going through all the basics. So what I'll be doing, at least for this first tutorial, depending on how it goes, is just I'll have the scene entirely pre-built. I'm going to go through how everything comes together through the pre-built script, everything that's in it, instead of building it by hand as we go. Also, hopefully that should lead to not having, from time to time previously, even I would get a little lost in what I was doing while I was talking and putting it together and cause confusion. So in this case, we'll just, we have it perfectly built, ready to go here, and we'll go through it bit by bit. Okay, so first of all, of course, we have the mesh turret here, and this is something I just built up real quick in 3D Max, nothing too special. We will also be having a tutorial on how to do that in case anyone's interested a little later, maybe not too important to the whole Unity series, but good to know if any of you are wanting how to build your own just right. Not that it's any real exact science, just helpful perhaps. Anywho, getting off subject here, so on this we have, I've built it in a couple parts just to make it easier to use, and that is a top level item, and then we have the turret ball, which is the part that's actually doing the aiming, and then we have a base. So even this could probably be merged into, well, it's actually best on its own, so sorry, ignore that. We have the ball, and then underneath each of the under there, I mean, is both the barrels, and this way, when the ball moves, of course, the barrels move with it, but nothing else does, which is exactly how we want it to work. And then on the top level, we can add our script and all that. That will then affect all the lower parts. Underneath each of the barrels, we have a muzzle position, and all this is basically a node or a socket where we want things to happen. In this case, I just created an empty game object and then positioned it exactly where I want the bullet to come out for each of the barrels, and also where I want the it also works for where the particle effect originates at. So pretty simple, just drag and drop it in like such. And these are all about the same. I have some just basic, simple materials dropped on them, nothing special. Then if we move up to the top level of this, is where all the magic happens. On here I have a couple components. Number one, I guess we'll look at not the script, everything else. I have a sphere collider, first of all, and what this is doing is actually essentially the turret's range. So whenever, in this case, whenever an enemy enters that collider, it's going to tell the turret, there's an enemy in range, start shooting at it. So this is a quick and easy way of doing it, and you can very easily set the range of it by just setting the radius of the sphere collider. Pretty simple. You could use even a mesh or a cube collider or something if you'd rather. It doesn't matter. Just this is a really easy way to set a nice spherical range for the turret. So simple way to do that. Then of course an audio source, which is just playing the fire noise when it fires. So moving on to the complex bit, we have the actual turret script with a couple options in here. Number one, the projectile, and that is just a projectile I created, which if we take a look at it here, oops, there we go. So all this is a simple sphere, some sort of cannonball perhaps, with a trail render on it. And trail render is something I don't think we've gone over before. It's kind of neat. It makes it so that as the object moves, it leaves this cool little trail behind, just like it sounds, I suppose. And a lot like the particles, if you remember those, probably you just set the color that you want it to change between. In this case, I have it going from red down to a yellow and slowly fading out. And it will do that as it moves along. Creates a really neat effect. Very useful for things like this. If you're moving it around in the editor or not in play mode, it looks a little funky because it never actually ends. So don't worry, it's not going to look like that. As we see if we hit play. Oop, actually it just ran off and disappeared because it has a script to make it move also. We can take a look at that. So anywho, projectile has a nice little trail render to leave that behind. And then we have a cannon projectile script on that. So we'll take a look at that first. It's probably the simplest part of this. Okay, so on here we have a very simple little script. All it's doing is, first of all, we have a speed and a range that we can set. And the speed is just how fast it moves. The range is how far it will go before destroying itself. You could also use that for, say, you could make another function so that when it reaches its max distance, it does an explosion, or who knows what, even turns around and comes back if you wanted to. Just what anything you do with that. So, looking in here, simple function update. Every frame, once it's alive, so basically when we fire the cannon, this is instantiated, spawned into existence, and it instantly starts doing this. We'll simply do a transform.translate along the forward axis, which is the Z right there. Don't forget to check also that if you have local or global swapped, in this case we want it to be local so we can see what its transform.forward is. For example, if I rotate this around, and then according to the global axis, which is basically the same thing as the view cube is showing here, this is forward, but that's not actually the case with this object. Its local is actually going in this direction. So be careful with that. It's good to check its actual direction there. Because with the script we're saying move vector 3.forward, which will move it forward along its local z-axis. You can also force this to be in world space if you'd like to. Just maybe something for a different tutorial to look into. Not useful here, but if you need to, there is an option for it. So anyway, it's moving forward at its speed times time delta time, And I think we've gone over this, but basically time delta time is just getting the exact amount of time that has passed since the previous frame. So this allows us to move that bullet instead of being simply, in this, if I didn't have this, it would be my speed every single frame. So depending how fast the actual computer is running, if you didn't hard limit the frame to exactly a certain number, it can move at any speed it wanted to. You know, if you're moving at 10 frames per second, it's going to move at 10 units per second, and 100 frames per second is going to just fly out of there. So using time delta time is a really nice little way to make sure it moves per second. So it's moving, in this case, 10 meters per second if we keep that variable there. Okay, so second we have my distance, which is a little just a private variable. By making it private, it doesn't show up here in the inspector. And in this case, we don't want it to be seen because it's simply used internally. And all this does is check, again, time delta time times speed. And if you remember way back in, or maybe currently, I guess, for some of you in high school, we have the time times distance equals, or sorry, time times speed equals distance. So this is the distance it's traveled, which is, of course, again, the time for this frame times the speed. And we're just adding that. This plus equals adds it on each and every frame. And then we check if the distance is more than the range. So if it is, then of course destroy the game object. So pretty simple and straightforward. Move at a certain speed per frame. If, keep adding the distance up. If that distance is more than the range that it should travel, then destroy it. So straightforward, just works simple and well. If you wanted to take this a little bit further, you could, again going back to the Lunar Lander tutorial, take a look at how we did the physics, and you could actually have your cannon shoot this with real physics, and it would launch out or lob and use gravity and all sorts of fun things. But since we're just, want to keep this simple for now, especially if we're targeting any kind of mobile platforms, iOS or Android, the simpler the better. You'll definitely want to be, saving CPU cycles for what you can, and physics are kind of heavy. So just doing it this way. Alright, so let's move on to the turret script itself. I'm going to just delete this projectile from the level. Alright, so on the turret script things get a little more complicated, but not too bad. Inside of here we have a couple variables again. We have the projectile. Let's try and get this to fit here. So as you can see in the inspector, there's the projectile, reload time, turn speed, fire pause time, muzzle effect, arrow mount, the actual target, muzzle positions, and the turret ball. So a bunch of different things that are making this all work properly. Going through them each, the projectile obviously is that projectile we just went over, and that's simply, you create it and then drag and drop it in as a prefab and then drop it into that slot, like such. The reload time is how many time or how long in seconds it takes, to reload the guns or whatnot before it fires again. Turn speed is how quickly it can turn and aim at the object. Fire pause time is just a little extra variable I added, which makes it feel more realistic when it fires, so that it, when the gun turns, it will, and once it fires, it will pause for a second, just like in real life. If a tank was turning its turret, it would turn, have to pause while it fires, and then go on to turning again. This way, otherwise it's constantly turning while firing, and it just looks bad. So we'll go over that in the script. Should be pretty straightforward. The muzzle effect, of course, is just the it's the particle that pops up as soon as the gun fires. So if we take a look at that real quick, just a very simple, quick little explodey particle effect that goes kerbloomy, obviously just emit with an auto destroy on. And yes, I'm still using the old particle effect system. There will be a tutorial on the new ones coming soon, I promise, but for now these work. They work fine. There's no performance hit or anything. They're good. We'll use them since they're easier, in my opinion, for now at least. Okay, so anywho, right, so muzzle effect is on there, and then the arrow mount is how much this gun is actually going to be off by. So 0, of course, means he'll always hit directly on where he's aiming, and just a higher number is more off, that's all. The target, that's something that actually could be a private variable. I just left it open in the inspector so I could see and make sure that it's targeting something properly. But basically that's just whenever something enters, again, that sphere collider, the target is what it's aiming at. That gets assigned there. The muzzle positions are both of these, left and right, and the script uses those to know where to spawn the bullets and the muzzle effect. So you can see if we click on each of those, it shows. And the turret ball, of course, is just the actual ball here, and that's because the script doesn't want to turn our actual game object, because then the whole thing would turn and wouldn't be proper, the base and all. We just want to turn this part, of course. Okay, so let's take a look at the actual script then. Going through this. I believe the best way, and again, feel free to let me know in the forums exactly how this works. I'm hoping it'll be a lot better. We can go through nice and quickly and keep things rolling by doing it this way, but, let me know. I'm going to go step by step as if this were in the game and just show how each of these parts, each of the parts of the script come into play and explain them through instead of putting it together piece by piece, which takes quite a bit longer, I've found. So, the very first thing that's going to happen in this, of course, is our function start. In this case, nothing happening, so nothing's going to happen there. Then, in the function update, we're checking if we have a target. So again, this is happening every frame, of course. If we have a target, we're going to do a bunch of stuff. Starting in the game, of course, there's no target. It's just going to sit there. Nothing will ever happen. So to make that happen, this variable needs to become true. And what I'm doing here is you don't always have to use a boolean, to see if true or false. You can actually just check if something actually exists. So in this case, I'm checking if my target. This is really saying if it's not null, and of course it starts out as null because nothing, it has no target at all. So it's sort of a nice way of not having to have an extra boolean to check true or false. If I have a target, simply check if the target, is currently assigned. So simple way to do that. Okay, so we know we need this in order for something to happen. So if we scroll down a bit, we have the, where did it go? Ontriggerenter. All right. Again, something we've looked into in previous tutorials, using it maybe a little differently here, maybe not so much, we'll see. All we do real quick is, of course, when this function is called, this is whenever something has entered the collider that we have on this turret. So in this case, it is the sphere collider. So as soon as the enemy enters into that, it's going to call the Ontriggerenter on our script automatically. We don't have to do anything about it. Only thing actually is that this object, the turret must have isTrigger checked. Otherwise, that's going to be an actual collider that things will bounce off of, which we don't want. We just want it to be basically a volume that when something enters, this part of the script is called. So make sure the trigger is checked. And the second thing is, whenever you're doing an onTrigger or onCollider call, one of the two objects has to have a rigid body on it, even if it's not actually getting physics input. It's something that kind of annoys me sometimes, but just has to be that way. So if you take a look at the cube enemy, just has a simple rigid body on it. I've turned off gravity and put it on isKinematic. That way it's not using physics in any way. It's only moved around by its transform, as in moving like this, or being manipulated by a script. So very simple. Just make sure that the enemy object or whatever is going to trigger this has that on it. And lastly, we have a tag. I've created a tag called enemy and added that to it. And that is because, so next, so once we get this Ontriggerenter, and here it's just it's taking in what enters as a collider. And this other here could actually be anything whatsoever. That's a variable name that I made up. I just usually use other because it reminds me that the item is the other thing that's coming into this this trigger. So other is a type of collider. So I can check if other.gameObject.tags. I'm checking if this object's, the entering object's tag is enemy. Then obviously an enemy is just entered in, and we want to do some stuff. So in my case, first thing I do actually is set the next fire time to equal, just a bit ahead. And this next fire time is just like it sounds, the next time that the turret is going to be allowed to fire. And I make this wait just a little bit first because otherwise the instant that enemy comes into range, the turret is going to realize, I have a target, bam, I'm going to fire right away. Which of course doesn't work because he's not pointing, most likely not pointing anywhere near the target. It just doesn't make sense. So adding a little bit of time at the front allows him to turn and face and aim and then fire. So I just did the reload time times 0.5. So half of the reload time seemed to work well. Something you can change around a bit if you'd rather. Okay, so next we get the actual target. So we just tell the script my target, which is again the variable up here, my target, and it is a transform, equals other.gameObject.transform. And one little thing here, we're not just grabbing the game object because it always makes things a little quicker if you don't have to step through these levels any more than possible. So I'm directly setting the transform because that means when I go to target this object, I don't have to later say, target position equals my target dot transform dot position. I can simply say my target dot position. One time moving, I'm not sure what the technical term is, one time moving through the list, I guess you might say, versus all those, get component calls, I think they are basically, can slow you down if you have tons of them happening. And if you have lots and lots of enemies, you might just have tons of these. And in the end, again, it's just one more thing to make the performance a little better. Okay, so we're targeting the transform of the object. And now that we have a target, we move on up to the function update is now suddenly going to function. So the next time the next frame that rolls around and this script gets run through, the function update is going to say, aha, I do have a target, and now we're going to check a few more things. So first of all, if time.time, so the time in the current game, is greater than the next move time, then it's going to try and aim the actual turret. So what this checks, first of all, is just using this next move time variable, which is something I've set up so that, again, just to make it a little more realistic, when it aims, it pauses for a second and then aims again. So that way, and I think I went over this a few minutes ago, basically it just makes it look more realistic and doesn't keep constantly turning. So if we have gone past that time, then we're going to calculate the aim position. So this is a function that uses the target's position right here. So it passes that along. Let's take a look at that. So calculate aim position is right down here. And so it takes in my target.position, takes it in as a vector 3 right here, and then it does some stuff to it. So first we create just a little temporary variable called aim point, and this is just exactly where point in the world that the turret is going to aim at. And that is a vector 3, of course, it's a position. And we take the target position, which we get from up here. We take that .x plus the aim error, the target position .y plus the aim error, and the target position .z plus the aim error. So this way, we're just setting, a little bit of a random amount onto each of the x, y, and z points, so that the turret just seems to aim a little differently each time. And you could take that out if you'd rather shoot exactly. I think it's nice just because you can, let's say maybe one of your upgrade options for the turrets later on if we get to that, or if you're doing it yourself. It leaves a nice room for one of your upgrade options to be upgrading the accuracy each time. Just a nice little extra you could add. So one thing there, just adding a bit extra. Then we want to choose a rotation for this, and it gets a little complex here, but I've tried to break it up by using these two different variables. You could technically do this in one, but the desired rotation is where we want the turret to actually rotate to, or what its its quaternion rotation should be. And quaternions are kind of ugly and complex. Instead of having just 3 x, y, and z, they actually have a fourth, which is a w, and they're almost impossible to understand, at least in my opinion. So they're magic. Just use them. They work. And they're the standard. They're actually the Unity standard rotation system. You can technically call Euler angles and X, Y, and Z, but it causes problems I've found, so it's best just to use these as quaternions. And it should make good sense anyway. So basically, the rotation we want equals a look rotation aim point. So all this is basically saying is we want to be at a rotation where we are looking at the aim point. So we're looking at the point at which the point at which we want to aim. I guess that makes sense. Okay, so simply that. So we're going to calculate the aim position. So again, this is happening every single frame that we have a target, and it's been long enough since we last moved. We're going to keep aiming at that target. So, or we keep getting the aim position, and then here we're going to actually rotate the turret ball. So we just say turret ball dot rotation. We're going to set this directly equals quaternion.lerp, and all this does is lerp is just a gradual change from one to another. So it's going from its current rotation to the desired rotation, which again we just figured out in the calculate aim position here. And it's doing that, so again we have the start, the end, and the amount to do it. So here we're using the time delta time again for a little trick that I've found works well. Normally this is a variable from 0 to 1, and you'd want to slowly raise it from 0 to 1 over the course of a set time or some such. But in this case we don't really have an exact time, we just want to be constantly aiming at the target. So if you use time delta time times turn speed, it will always be less than 1, but getting closer and closer and closer. So time to delta time, or unless you have a really long frame, if a frame takes longer than a second, so first of all you have some major performance issues, something else needs to be done, but at that point you'd have a problem. But otherwise time delta time will always be less than 1. So you can safely multiply that by your turn speed, and it will not cause any problems and just always be a little bit less than all the way aiming. So that just keeps it moving closer to this desired rotation from the start rotation. Okay, so we're doing that, we're rotating it toward it. And then secondly, now that again we have a target, so this is all happening. So after this had happened, the aiming has happened. If the time.time, again just checking the time, is greater than the next fire time, so when we want it to be allowed to fire, then we're actually going to fire a projectile. So let's take a look at the fire projectile. So down here, the first thing we do is simply play the audio out, which is just whatever the default audio is set as. And then we set up this next fire time. So we just want to tell the script to not be able to fire until the amount of time has passed, that is the reload time. So pretty simple, we just say next fire time equals time.time plus reload time. Nothing more than that. The next move time, we do the same thing, because now that it's firing, we want to set that quick little pause during the fire. So we say next move time equals time.time plus the fire pause time. So that will of course be less than the reload time, so it just pauses and then keeps moving. We're going to calculate the aim error at this point. And we're doing this right here instead of in the function update, because I found that if it's constantly refinding the error amount, the turret just looks like it's bouncing around constantly and goes absolutely bonkers. So I just do this each time it's going to aim, which makes sense. It's as if you were, aiming, your own rifle or something at a target. You would aim and there'd be a certain error amount and you would fire, and again and again and again. So in this case we only do it right after firing, so that we the next time we aim there's going to be a certain error amount. So this function, take a look real quick at this one. Very simple, it just says the aim error, which again is the aim error that's used up here when we're getting that aim point. This aim error equals just a random.range negative error amount to error amount, and that just makes sure, say if you set your error amount to 3, we're not only erring to the, in the positive direction, it could be in a completely 3D error amount. So just does a negative to a positive of that number. So that's going to be somewhere in between those two numbers. So in my case, it's what do I have it set as? 2. Oops, sorry, error amount here, 2. Yep. So anywhere between -2 and +2, and that's a float. So it could be 1.7589, or it could be all the way up to exactly 2. One thing to remember: if you use an int in a random.range, it will never equal the end amount. So if I said, aim error as an int equals random.range, negative error amount, positive error amount, and if the if the error amount was 2, I would only get 1, 0, or 1. You'd never get the end, the extremes of the values, basically. So just remember. Or sorry, that's a lie. You will get the lowest amount, but never the top amount. So you will get -2, -1, 0, 1. Just in case you run into a problem with that, I have before, and it frustrated me for hours before I figured out what was going on. However, with floats, you get the whole thing. Okay, so we calculated that error amount. Now we're going to do some more exciting things. So for the muzzle and muzzle positions, and what this does here, of course, is just run through using a for loop each of the muzzle positions. So in theory, you could have as many barrels as you want. You could even just, I guess just for example, let's do this here. If I select each of these barrels, and they actually have a muzzle in them already, so we'll take those, and I'm gonna copy them. And now we've got 4 of them going on here, and we'll add a couple more just for fun. Alright, so crazy turret, and I'm going to delete those bottom 2 just to make this easier on myself. We now have to, of course, go in and add each of the muzzle positions. Let's see here, select these each. I'm just going to move these down a little bit so they make more sense. Okay, so we have to assign each of those new muzzle positions. Right now the size is 2. If I just go through, make sure and drop in each of the new ones. There we go. And now, assuming I haven't broken anything, there we go. So it still works just fine, and that's one thing I like to try and build into scripts, is the ability to adapt to what's being given to them. So in this case, it just automatically knows to run through all the barrels. It's not set to a certain number or some certain exact ones. They're not hard-coded in. You can quickly and easily, this could be another really cool upgrade. Add some more barrels, whatever it might be. Lots of fun stuff you can do with that. That's actually pretty nice. I think I should leave it that way. Okay, so again, it's running through all of those, and then just quickly first instantiates the projectile. Again, the projectile that's set here in the script for the inspector. Drops it in at the muzzle position and the muzzle's rotation, so that way it's going to be facing right down the barrel to start with, and does the same thing for the muzzle effect for each barrel. One quick note on this: the muzzle, the muzzle position. Make sure, just the same as we did with the world and local rotation, that you're doing the same for these. Just in case, in my case, it is correct already, but make sure in the local that your Z is pointing down the barrel, because that's going to make it work correctly. Otherwise, just for example, if I take each of these and rotate them so they're not actually pointing down the Z, you see they come flying out in a crazy direction like that. So obviously we do not want that. Let's put that back, make sure I didn't break it. Okay, so just make sure that your muzzle position is facing the right direction, because it is spawning the bullets and the fire effect in that direction. So we have that, we're firing it out. I believe that's pretty much it for how this is all working. One last thing I think I'd like to go over a little better that I don't think really was explained well enough is the firing time. And with this, it'd be great if people let me know if I'm wrong or right about how this this new method of sort of showing how to put things together a little more quickly this way. If it works well, let me know. I'd love to hear if I should keep doing it this way, or if I even, heck, if I need to redo this in the old way, no problem, just let me know. But hopefully this will be a little less, painstaking and tedious, especially for those of you who've already gone through all the tutorials, which you should do. Make sure you go through those before getting into these, because they will be more advanced. Anyway, we're talking about the firing times. So just in case this didn't make perfect sense, because we kind of skimmed over it a bit, the fire times, all this is doing again is finding the current time, adding on whatever amount we want to, and then wait until the time equals that new amount. So basically, if the time is 10 seconds into the game, we fire, and my reload time is, say, 5 seconds. It's going to log that, so as soon as this comes by, the next fire time is going to be time.time, which is 10 seconds, plus the reload time, which was 5, so the next fire time equals 15 seconds. So now, going through the update, what's going to happen is, so let's say 1 second later, if time.time, which is going to be 11, equals next fire time, which again is 15, nope, not going to do anything. 12, not going to work. 13, 14, obviously not going to work. 15, it will work, and it'll go ahead and fire. It'll do the same thing, add another reload time, let's say 5 on, now it's 20, so that's going to keep going. Same thing for the move time, same exact concept. And we have the greater than or equal because, again, one thing that I got stuck on for a little while, and to many of you more advanced scripting people, if you've worked with other things, you're probably like, duh, but for me, wasn't right away. I used to use just an equals, assuming, of course, it's going to equal the fire time, but actually, in a lot of cases, it never will. It'll be, actually probably 15.257 or something. So it'll go, the frames aren't exactly per second, so it'll end up going over. So you always want to check for greater than or equal to, or if you're going the opposite direction, less than or equal to. In this case, at least for time factors like this. So that's it. Just wanted to go over that one last bit real quick. Again, let me know if you have any questions in the forums. This should be a really fun series to be going through. In the next tutorial, we're going to add in some real AI onto this turret, which is something that I'm currently working on building. A little trickier than it seemed at first. It was going to be part of this tutorial, but looking at the time, actually, that is a good thing. Because I guess if you notice, let's play this one last time. As I'm moving this, the turret is not smart enough to aim ahead of where it's moving, which takes a bit of vector calculation and some fancy stuff. But we'll get into that in the next one. Definitely something that will be needed. Okay, great. Hope you guys enjoyed this, and are looking forward to the future ones. Let me know if you have any suggestions for, turret types or things like that that I can try and put into this series. It's definitely going to be very modular. Putting things together as we go. Learning experience for myself as well as you guys. Should be a good one. Okay, thanks for watching. See you in the next one.